Hi, this is Lady Lex UK and here's another tutorial for Project Spark. Now we're going to be doing something a little bit more complicated today. I've had a request to have a look at AI pathfinding. Now there is a video available from the Team Dakota community team. If you go to my website projectspark.co.uk and search for AI pathfinding, you should be able to find that video quite easily. It's over an hour long. It's a live education stream. It goes into quite a lot of complexity about AI pathfinding, so you could use that video. This video I'm going to go into a more simple version of pathfinding. It has all the principles there, but it is a little less complicated and a lot less lines of code. So hopefully you can take this and expand on it, make it your own, make it do what you want it to do. So what is AI pathfinding, first of all? Well, as you can see in my world here, I've got an awful lot of logic cubes all laid out on the ground. They're not in any particular order. I've tried to do it in sort of like a grid, but they are particularly randomly placed, really, in amongst all of our objects. And the idea is a non-player character should be able to navigate themselves from any point to any goal by moving from logic cube to logic cube. So it will work out a route based on proximity of cubes to each other and proximity of cubes to your goal. So let's see it working. So I have a character here. And when I walk into that green area, he's going to start on his journey. There we go. So he's off and he's walking from cube to cube and he's in search of the goal, which is that heart over there. So he's trying to find the quickest route and he's found it. He's jumping up and down and there he is at the heart. And just to show you that it is working out the route dynamically. Let's put the heart, where should we put it? We'll put it behind there. So he's off. Slightly different route to last time. Where it's going, where is he going? Oh, he's found it. He's jumping up and down. There we go. He's found the heart. And he's very happy about it. Okay. So how is this done? Well, if we look at our follower character here. First of all, nothing happens until the global Boolean start is true. And that is... that happens when my player walks into the trigger zone of this platform here. So once it's true, it then pops the character follower into a object set called global NPC. It's incremented by me, and the follower will then move towards an object called target with a minimum distance of 0. That means it will get to the center of that object. And when the page is entered, its goal will be the same as whatever goal is set in our player. And then it will work out its nearest node. So it will say the nearest node is the nearest object within the object set global nodes, and then it will set as its target that nearest node. Now the global nodes are all of those logic cubes, and that's set in the logic cubes. You'll see that in a minute. When the distance to our goal is less than 2, then he'll start to jump. And that's it. We'll ignore this line for that. That's for the next little bit that I'm going to show you. So that's it. That's all of his code. That's all he needs to do. Now the rest of the code are in these nodes. Now what I have done to make it easier for myself is these nodes here have got this in their brains. Once, add brain, node, and that's that green node there. So if I wanted to change the brain of these nodes so they do something slightly different, I only have to change one brain and it will change all of these little white ones. That's the best thing to do when you're making something and you need lots and lots of brains to be identical. Otherwise you have to keep deleting and then placing them again. So let's have a look at this node brain. It says once global nodes, you saw that in the other brain, global nodes is incremented by me. So all of these nodes are then added to this global object set. Now this part of it will turn the visibility of those cubes on and off. Now as a default, logic cubes are normally invisible, but with this code I can make them visible or non-visible as I like, and it's quite handy at the beginning when you're building something for them to be visible. You change that to false when you want them to be invisible. The goal is the same as the wooden puzzle goal as before. Now the distance to goal is a number variable, which is literally the distance to the goal. So it's determining how far away is this node from our goal object. And for debug purposes, I'm displaying that above the cube, but obviously you won't need that for your game. And for debug purposes also, I'm going to display a number which will tell me how many nodes is left in its node set, but we'll explain that in a minute. Right, when you detect a global NPC character, so one of those characters that has been placed in that object set, then my NPC equals it. Then we're going to make a copy of the global node set, and we'll call that node. So that's a local node set. And we're going to say our next node is our nearest object in that node set. So that the nearest node to the node that the player is standing on is our next node. And then we're going to query that node and say, is that node's distance to goal less or equal than my distance to goal? So is it closer to the goal or than I am? And if it is, then the NPC character's target will be that next node. Else, that node is removed from our local node set, and then it will run it through again until it gets one that is the target of the next node. Unless we get down to a node count of 1, which means only the node that the player is standing on is left in that node set, in which case that node must be the closest one to the target, so the next target for that non-player will be the goal. And that is it. So if you wanted to just do a treasure hunt, a bit like in Fable, we had a dog and it goes sniffing out treasure, this would be one of the ways that you could do it. So it just searches for our goal object, which this is our goal object here, and this is set in the player brain. When global start, goal object equals that heart pickup. Now I want to show you how you can use it for enemy tracking. So instead of having the heart as the goal object, we're going to set the goal object to be my player character. And in this character brain, I'm going to, instead of jumping when we reach the goal, we'll say when the distance to the goal is less than 20 meters, then we're going to switch page to seek and attack. And I've added an enemy brain on page 2, which is the seek and attack brain. I've put in a hologram code here just for debug purposes, so I know when it's in attack mode. And this is just a basic enemy brain. The only difference is when the distance to the enemy is greater than 20. So if you manage to run away from the character, it will switch back to page 1 and it will go back into search mode. So let's move our chaser away from our player. Let's pop him over here somewhere. And over here I've got another chaser, and this time he's going to be armed with a bow and arrow. His code is exactly the same on the first page, except his second page has got some slightly different code. So he's going to equip a bow, and if his distance is between 10 and 20, then he's going to turn towards the player and fire at them. If his distance to the enemy is less than 10, then we're going to set a boolean called action, and that's going to be a randomized 3 numbered random number, and it's going to be a randomized action. So either he's going to move away from the enemy, or he's going to move towards the enemy, or he's going to attack the enemy. And then once he's been hit by an attack, or is it hits the player, then he's going to start to move away again, move away from the enemy. And you can do that for 3 seconds before that action is false, and then he goes back to doing the rest of the rules. And if random 3, he's going to move with strafing in the direction of right again for 3 seconds until that action is done with. And if the distance to the enemy is greater than 20, then he's going to go back to page 1, and he's going to start searching for the enemy again. So I think we've changed everything. Let's try it out now. So I'm going to move into the zone and start them off and see what happens. Are they running towards me? Here they come, coming from different directions, you notice, but they are still heading towards me. He's got range, he's now firing at me, and the melee enemy is upon me. Right, I'm going to kill the melee enemy, so he's nice and easy to kill. Alright, and let's see if we can move and get this ranged guy. Oh, he's moved off because I've hit him. And now he's strafing. So he's going to be much, much more difficult to kill now, because his instructions are to move away from me, or strafe, or move in for the kill like he's done now. And now I can get him. But he'll run away if I stop fighting. So there you go. There's how I've used Pathfinding to do enemy tracking. And just to prove that enemy tracking works regardless, let's test it again. I don't need to be still. I don't need to stay in the same place. I can move around. So, oops, I've got to set them off. Let's set them off. Right, got into the trigger zone. I've set them off. And now I'm moving. I'm a moving target, and they are still heading towards me. Now I can run away. Hopefully I can get away. And now they're searching for me. And they found me. There we go. So that's how to do enemy pathfinding, AI pathfinding, and treasure pathfinding. I hope that was useful for you. It is a much simpler piece of code than the one that is normally quoted for pathfinding, but I think it works quite well. So thanks for watching, and keep sparking.